We know that butane has 4 sp3 carbons, so the angle at each carbon is 109.5 degrees. But when considering butene with 2 sp3 carbons and 2 sp2 carbons, the second carbon at the sp2 center has an angle of 120 degrees. Because of this difference in angle, the distance between the hydrogen and the methylene, CH2, attached to carbons 3 and 2 respectively in butene, is greater than the corresponding hydrogen and methyl, CH3, in butane. Thus, there is a reduced steric strain for the butene eclipsed conformation. Let's consider the anti-staggered conformation viewed down carbon 2 red to carbon 3 blue in Newman projection. Upon anti-clockwise rotation about the 2,3 carbon-carbon bond by 60 degrees, the eclipsed conformation is generated. With butane, the largest population of the two conformations is the anti-staggered conformation, due to the 16 kilojoules per mole lower energy than the eclipsed conformation. Now, what about the butene case? Here is the anti-staggered conformation viewed down carbon 2 red to carbon 3 blue in Newman projection. Upon anti-clockwise rotation about the 2,3 carbon-carbon bond by 60 degrees, the eclipsed conformation is generated that is more abundant than the anti-staggered conformation. This is due to the wider angle in butene, and the eclipsed conformation is of lower energy by 5.5 kilojoules per mole when compared to the anti-staggered conformation. Let's contemplate butene. We're viewing it down the bond from carbon 2 red to carbon 3 blue. Here's that view in Newman projection. It shows the anti-staggered conformation with the highest energy of all the conformations. There's a dihedral angle from carbon 2's red hydrogen to carbon 3's blue methyl group of 0 degrees. Carbon 3 blue is rotated by 60 degrees anti-clockwise, decreasing energy until arriving at an eclipsed conformation that has a dihedral angle of 60 degrees. Keep going with a further 60-degree rotation, causing an increase in energy to the gauche conformation at a dihedral angle of 120 degrees. Now that's very similar in energy when compared to the anti-staggered conformation. Another 60-degree rotation sees another drop in energy to the syn eclipsed conformation with a dihedral angle of 180 degrees. From here, another 60-degree rotation, increasing energy to yet another gauche conformation of 240 degrees dihedral angle. Guess what? Another 60-degree rotation lowers the energy to another eclipsed conformation with 300 degrees dihedral angle. And finally, the last 60-degree rotation increases energy to the same anti-staggered conformation we began with, having a dihedral angle of 0 or 360 degrees. The eclipsed conformation has the lowest energy of all the conformations, whilst the anti-staggered conformation has the highest energy of all the conformations, greater than the eclipsed conformation by 5.56 kilojoules per mole. Almost identical in energy to the anti-staggered conformation is the gauche conformation, having 5.52 kilojoules per mole more energy than the eclipsed form. Ultimately, the syn eclipsed conformation has 2.0 kilojoules per mole more energy than the eclipsed conformation.